Hello, this is Professor Urbis White. Today we will talk about quadratic equations that do not look like quadratic equations at first, but you can reduce them into quadratic equations. So I'll give you some examples of that. Okay, quadratic form. The quadratic form is ax squared plus bx plus c. That's the standard form. In these set of problems, you may be asked to factor or you may be asked to solve a quadratic equation. So let's start with factoring. When somebody says factor, here it is. You go and you factor. You have 1 and 1. 1 plus 1 is 2. X plus 1, x plus 1, x plus 1 squared. You factored. So you know how to do that. You may want to factor just to find the x-intercepts, or you're just asked to factor. So that's easy. What happens when you're asked to factor this? Okay, so let's go one step at a time. All right, this doesn't look like a quadratic equation until I do some to it. Here we go. Look, this is quantity squared, quantity, and a constant. Quantity squared, quantity, and a constant. That's a quadratic equation. So how does that work? Quantity plus 1 times quantity plus 1. Now 1 plus 1, that's 2. X plus 2, x plus 2. Okay, I actually factored. Okay, this one gives me x plus 2, which is x squared plus 4x plus 4. Is that really true? You can kind of go and play with it. Go to your original equation. Here's my original equation. And square it out. X plus 1 squared is x squared plus 2x plus 1. And fold this out in 2x plus 2. And then you have a 1 and a 1. All right? And what does that give me? X squared. You have 2 plus 2, that's 4. And you have 1 plus 2 plus 1, which is 4. Amazing. It is actually the same. All right. So this method works. So all I have to do is just kind of look at it as like quantity and kind of squint my eyes and do the problem. All right? Well, let's see if that works for everything else. So let me write the procedure that I came up with. When you suspect it's a quadratic, make a substitution so that u equals something and it looks like a quadratic. All right? And this f of x is like any function of x. Handle the new equation in u alone, and then you substitute back in your initial way, okay, which is probably an x or a t. So what does that mean? Let's do it. Now I'm asked to factor. I'm going to pick this. So I know that a quadratic equation looks like this. Squared something plus something else, right? So I'm going to look at this quantity together. I'm going to call it u. Now I'm going to write f of u equals u squared plus u minus 6. And remember how I factor this. This is going to be plus 1, so it's going to be 3 times negative 2. And this is going to give me u plus 3, u minus 2. And then you go back to your original equation. You have to put x back in there. What was u? U is x minus 1. U is x minus 1. Clean it up. X minus 1 plus 2, that's 2. Minus 1 plus 3, that's 2. And this one is minus 1 minus 2, that's 3. Okay, so I did my steps. I did a substitution in terms of u, factor it in terms of u, and put the x's back. Okay, I can do that. So let's do some more. Uh-oh. So the only thing is you need to think of this step. I'm giving you the steps so that you know. So I need a square, but I have a fourth. So I have to look at a square of a square. Okay, so let's do that. What is f of u then? F of u is going to be u squared, because when I square u, I get x squared squared, which is x fourth, right? So u squared is x fourth minus 5. X squared is u plus 4. Okay, how do I factor that? Negative 1, negative 4, product sum. You learned this in beginning algebra. So you go u minus 1, u minus 4. That's my f of u. Now go back to x. X is going to be, instead of u, go put your x back. What was my x? U equals x squared, so let's put x squared. And I have, guess what happened right now? I put it back and I look at it. This is also factorable. And how does that factor? That's x plus 1, x minus 1. This is also factorable. How does that factor? X plus 2, x minus 2. Oh my goodness, look what I found. By doing the substitution, do it down, and then at the end, I have to factor one more time. Okay, let's look at this. Again, I'm giving you the thing. So u equals x to the negative 1. That means u squared is going to be x to the negative 1 squared, which is x to the negative 2. Okay, I can do that. So this time they're asking me to solve. Okay, I can do that. Now I'm going to write everything in terms of u. U squared minus 5u plus 4 equals 0. Okay, then I go and factor. Negative 1, negative 4, u negative 1, u negative 4 equals 0. Since I'm asked to solve right now I'm going to go solve for u first. U equals 1, u equals 4, setting each factor to 0. Now do the substitution. What was u? X to the negative 1. And what was u? X to the negative 1. I have to do a little bit of work. 1 over x equals 1. Cross multiply, you're going to get 1 equals x. This one is 1 over x equals 4. Cross multiply. So you have 1 equals 4x. X equals 1/4. Do you see it? Okay, very good. So when I'm asked to factor, you just go to u, come back to x, and you factor. When you're asked to solve, you go to u, you solve, put the x in, and get the x values. All right. Let's do this problem. What does this mean? This means u equals x to the 1/5. U squared is going to be x to the 1/5 square, x to the 2/5. Well, let's put it back. That means u squared plus u minus 6. Okay, let's do it with product sum. This is the product sum of 3, negative 2, u plus 3, u minus 2. Set each factor to 0. U equals negative 3. U equals 2. Now substitute back. What was u to start with? U was x to the 1/5. And this was x to the 1/5. What am I going to do now? To get rid of the 1/5, I need to actually take the 5th power of both sides. So what do I get? I'm going to get x equals negative 3 to the 5th power, and x equals 2 to the 5th power. Okay, does it make sense? Let's do another one. U equals rad x. How do I know that? You kind of know how that works. You just go to this term, and that term actually gives it away. And u squared is x. Okay, so let's go put it in. U squared minus 5u. Now, I have to move this over there. Set it to 0 because I don't do the solving unless I have a 0 on the side. This one is negative 1, negative 4. So I'm going to have u minus 1 times u minus 4. Solve. U equals 1, u equals 4. Am I done? No. You have to go back. What was u? Rad x equals 1. What was u? Rad x equals 4. Okay, at this point you may be able to eliminate some of the answers if this gives you negative or something. Just pay attention to that. Now what am I going to do? I'm going to square both sides. Square both sides. What are you going to get? X equals 1. X equals 4 times 4, 16. So I did 3 or 4 different types of those reducible to quadratics equations. Just always look at this term, not the square term, and that gives away the substitution.